Hello, 8th graders. I hope you noticed that I have a different background. So this is a place I wish I was right now at the beach. I'm not actually at the beach. I'm still in the same chair at the same desk that I was at from home, but at least it looks pretty cool. So today we are going to be covering lesson 7.2. This is going to cover pages 203 to 208. This is solving equations with rational numbers. So if you need to pause the video for a moment to get your math book, that would be great. And I'm going to be working from page 206. So go ahead, pause the video, get your math book out, and I will see you back in a minute. Okay, I want to go to that and 206. Okay, so here we are, and I'm going to be doing selected problems from page 206. Our standard today, and I'm going to pull down my tools here. Our standard today is going to be EE7. I can solve linear equations with rational coefficients using the distributive property and collecting like terms. So that is what we will learn. So let's just dig right in and start. We have our guided practice page 206, and I'd like to start with question number 2, this one right here. So there are two methods when you have fractions to solving these equations. And I'm going to show you both methods, and then you can choose the method that you like the best. So I'm going to turn off my heater here. Okay, so 3/4 n minus 18 is equal to 1/4 n minus 4. Okay, so the traditional method, we're going to call this the regular method, which is what we learned in our last video. Remember what our goal is. Our goal when we're solving equations is to get the variable by, remember, itself. Oops, itself. How do I do that? Using, anybody remember? Inverse operations. Very good. You guys are good. So let's move that up here. Let's keep that a little bit right here so we can see it. So my first step here is to look at, well, we've got a negative 18 and we've got a negative 4, and they need to be on the same side of the equals. So I'm going to move this negative 18 over to the negative 4. So to do that, I am going to need to use inverse operations. So 3/4 n, and I'm going to do the opposite of negative 18. I'm going to add 18. Remember, what you do to one side of the equation, you must also do to the other side of the equation. So we have to add 18 to the other constant. So if I do that, my little lines here, I am left with 3/4 n plus 0, I don't want that underlined, equals 1/4 n. And now we have a positive 18 and a negative 4. So what will that give us? Positive 18 minus 4, 17, 16, 15, 14. Right? Yeah. Okay. Now I'm going to drop the 0 because 0 plus any number is just the number, equals 1/4 n plus 14. Now I have to get the 1/4 n over to the other side with the other n coefficient. So Erase that now. I am going to use inverse operations. So I am going to subtract 1/4 n from both sides of the equation. Whatever you do to one side, you must also do to the other side. So if I do that, I now have, grab my little spotlight, 3/4 minus 1/4. What is 3/4 minus 1/4? Exactly, 2/4 n equals, now my 1/4 and my negative 1/4 is going to end up being 0n plus 14. Hello. Okay, so now I have 2/4 n equals 0n plus 14. I'm going to drop the 0n because 0 times any number is 0, and 0 plus any number is just the number. We end up with 2/4 n equals 14. Now, move up just a little bit here. I have one more step. This, let me pull these down here. This 2/4 n, we have to get rid of the 2/4. 2/4 n means 2/4 times n. So the inverse of times is division. And I could do this a couple of ways. So I'm going to show you division first. So I'm going to divide by 2/4 to both sides. And last time, I think I told you to use the reciprocal, and I'm going to show you why this works. Okay, so there. Now, when you're dividing fractions by a fraction, I'm just going to put this over here. So I really have 2/4 n divided by another 2/4. When you divide fractions, it's the same as multiplying the top fraction by the reciprocal of the bottom fraction. And the reciprocal is just taking the top number, the 2, and putting it on the bottom, and taking the 4 and putting it on the top. So it's flipping the fraction on the bottom. So now if I do that, let me change my color here. I have the 2's, which cancel out, and I have the 4's, which cancel out, leaving me with just 1. So that is why I can do that with the 14. Let's actually do that with the 14 too. So we have 14 on the top. Oh, I want red. We have 14 on the top divided by 2/4. So I'm going to put 14 over 1, and I'm going to put that all over 2/4, like that. Now that's the same as multiplying 14 over 1 times 4 over 2. You take the bottom fraction and flip it. Use the reciprocal. Now I can cancel. Let's bring down my thing here. Okay. I can cancel. 2 into 14 goes 7 times, and 2 into itself goes once. So I'm left with 7 times 4, or 28. So my answer then, the 2/4 will cancel out, leaving me with 1n equaling 28, or n equaling 28. Make that a lowercase n. Now, I wanted to show you what I showed you last time. I didn't show you the division part because watch what happens. So if I go back to this 2/4 n equaling 14, I can just right away, instead of going through all of this stuff over here, I can just multiply by the reciprocal of 4 over 2 to both sides. because that's what I did over here. I ended up multiplying by the reciprocal. So if I multiply by the reciprocal, the 4s will cancel out and the 2s will cancel out, and I'll be left with just an n on that side, or a 1n, equals, and then on this other side, I have the same thing I did before. I've got the 14 canceling into a 7 and the 2 canceling into a 1, leaving me with 7 times 4 on top, which then is equal to 28. So either way I do it, I get to 28, but the shorter way is to just multiply right away by the reciprocal. If you want, you can do all this, but I was just using that to show you why multiplying by the reciprocal is the same as dividing by the fraction. So we have n equaling 28 for our solution. I'm going to put that over here on our page. N equals 28 right here. And remember, I went back, I'm going to go back up here for a minute. I told you that was the regular method. There is a little bit of a shortcut method when you use fractions. We lucked out on this problem because the fractions had the same bottom number. The denominator was both 4. Sometimes that's not going to happen and you're going to get messy fractions. So I'm going to show you how to erase all this, how to use a shortcut method to solve. So I'm going to erase all that, and I'm going to move to a shortcut method. So this will be the shortcut method. We're going to use the same problem, problem number 2, so we can see how it works. So we have our 3/4 n minus 18 equaling 1/4 n minus 4. Now, I want to get rid of the messy fractions because I don't like fractions, especially if the bottom numbers aren't the same and I have to mess around with changing them to get the same bottom numbers. So what I'm going to do is I am going to find, and we put a text box here for this, I'm going to find the least common multiple, the LCM, of the denominators. So in our case, the denominators are both 4, so the least common multiple has to be 4. So I'm going to put parentheses around each set, each expression set on each side of the equals. I'm going to move this down one. And then I'm going to multiply the entire expression on both sides by the least common multiple of 4. So now what I'm going to do is I'm going to multiply the 4 times 3/4 n and the 4 times 18. And then over here, I'm going to multiply the 4 times 1/4 n and the 4 times the 4 there. So I'm going to write this out because then we can actually see the fractions. Excuse me. So we have a 4 over 1 times 3/4 n, right? Minus, we have the 4 times the 18. 4 times 18 equals, hopefully I'm not going to run out of room, we have the 4 times the 1/4 n, so we have 4, and I'm going to put it over 1, times 1/4 n minus 4 times 4. And I don't know if I'm going to fit 4 times 4. I'm going to try. 4 times, I did it. 4 times 4. Now, if you notice, I'm going to change colors. If you notice, the 4s will cancel out, leaving me with, back to a different color, a 3 on top and a 1 on the bottom. So any number over 1 is just the number. So I'm going to just say 3n minus 4 times 18. So what's 4 times 18? Should be, if you want to do the math, I did it ahead of time, 72. What I got? Yes. Equals, now I'm going to change colors. These 4's on the other side are going to cancel out, leaving me with just one n, or in our case, just n. So we'll just call that n, minus 4 times 4, which is 16. So now we got a regular problem like we've been doing. So we want to get the constants on the same side. So we want to bring the 16 over to that side using inverse operations. So I'm going to go back to typing that. So we currently have 3n minus 72 equaling n minus 16. We are going to, what should be equals? Equaling n minus 16, and we're going to add 16 to both sides of the equals, like we've been doing. I wanted to underline the entire universe here, just part of it. Hope you guys are doing well. Okay, so we are left then with 3n, and what is negative 72 plus 16 equal? It's going to be a negative number. It's 72 minus 16, basically. 62, 61, 60, 59, 58, 57, 56. So negative 56 equals, still have our n, and then these two, I think I can go to that extra step now and start crossing the negative and the positive off, because you know it's just going to be 0. So now we have to get our 3n over to that side. How do we do that? By using, you got it, inverse operations. So I'm going to minus 3. Well, I'm going to bring the n. I'm going to do it the other way. No, I'll leave it that way. I'm going to minus n to both sides. And because I want you to see anyways that what happens is it doesn't matter if the variable ends up on the right side or the left side, but we're going to have to make one extra step. So let me just erase some of the stuff that we've got going on here now that we've used that. Get rid of all of this. Make our screen a little clearer and get rid of that. And we can move up. Okay. So I am going to subtract 3n minus n is going to give me 2n minus 56 equaling 0, right? 1 minus 1 is 0. Now I have to bring the 56 back over because I did an extra step, but sometimes that's okay. Plus 56, and now I end up with 2n equaling, the 56's will cross off because they will become 0. So we have 2n equaling 56. Now our last step is to use inverse operations to divide by the coefficient or multiply by the reciprocal of 2, which is 1/2. Same thing, right? And if I do that, my 2's will cross off, and I'm left with just n equals, small n, equals 56 divided by 2, do the math, you will get 28. So you'll see that I have 28 here. Get rid of that. But I also got 28 up here. So the only difference was, in this one, I multiplied by the least common multiple to get rid of the fractions, and then I was able to solve it without any messy fractions. So that's a shortcut method that you can use if you would like to. You get the same answer either way. If that confused you and you don't want to use that, go right ahead and use the regular method with the fractions. Okay, I would like to move on to question number 5. Oops, don't want to roll that up. So let's move this one down. There we go. Okay, let's erase this. So question number 5 is 2.25t plus 5 equals 13.5t plus 14. Now with this one, there is a regular method and a shortcut method. The shortcut method, if you might have guessed, is very similar to what we just did. So I'm going to show you that. So I'm going to put parentheses around the expression on each side of the equals. And I'm going to multiply by something to get rid of the decimals. So can you think of what I could multiply both the left and the right side to get rid of the decimals? It's going to be a multiple of 10. Yep, I'm going to multiply by 100 to both sides. And remember, I'm multiplying the 100 to this number and to that number. And over here, I'm multiplying it to this number and to that number. Don't forget, you have to multiply by each number in the parentheses. So now let's do that. So 100 times 2.25. Remember, when you multiply by a decimal, by 100 or a multiple of 10, you move the decimal the number of zeros you have in the multiple of 10. So in the number 100, we have 2 zeros. So we're going to move our decimal 2 to the right, and that would give us 225t plus 100 times 5. 100 times 5 is just 500. And that equals, now we have 100 times 13.5. So again, we're going to move our decimal. We have 2 zeros in the 100. Move our decimal 2 to the right. So notice that I have an empty space here. I'm going to fill that in with a 0. So that's going to equal 1350t plus, now we have 14 times 100, so 1400. And now it's just a regular problem. So we are going to get rid of some of these extra things now. We are going to move the 500 over to that side. So I'm going to use inverse operations, and I'm going to minus 500 from both sides. Minus 500. And when I do that, I get 225t. And feel free to do these ahead of me if you'd like to if you're watching on video here. Plus 0, so we're just going to leave that off, is going to equal, let's move it down here so we can see that, 1350t plus, what's 1400 minus 500 here? Line that up better. We end up with a 0, a 0. We can't take a 5 from a 4, so we make that a 0, so it's 14 minus 5. So that should be 9, right? 13, 12, 11, 10, 9. So that should be 900. Let's back that up over here. There. Now we have to get the 1350t to the other side. So to do that, we are going to minus 1350t to both sides of the equals. Minus 1350t. Still got the plus 900. We'll put that in a minute. And if we do that, we get, it's not supposed to say equals, but say minus. Minus 1350t. We now get 225 minus 1350t. So I don't know about you, but that's the same as negative 1350 minus 225. 25 is positive. That's negative. So we're going to end up with a negative answer. Can't take 5 from 0. This becomes a 4. 0 minus 5 becomes 10 minus 5, or 5. 4 minus 2 is 2. 3 minus 2 is 1. 1 minus nothing is 1. So on this side, we're going to have a negative 1125 equals, and of course, I'm going to put the red back. This is going to cancel out to 0. And we will be left with 900. And this is a t. We've got to make sure we have our t in there yet. So now I have to divide by the coefficient of negative 1125 to both sides. Negative 1125 to both sides. And this is number 5, which then leaves me with t, because these cross off and become 1, except for the t. T is left equal to 900 divided by a negative 1125. Our answer is going to be negative something, right? So if you use a calculator to divide that out, you'll end up with 0.8. So the answer, I'm going to make that lowercase, is negative 0.8. So let's put that in for number 5. Negative point, or we could put 0.8, same thing. Let's do that. So that's the answer. Now that was using the shortcut method. We don't have to use the shortcut method. In fact, I actually think that in this case, it might have been easier to not use the shortcut method for this. So let's see what would happen. If I were to do that, I would just have 2.25t plus 5 equals 13.5t plus 14. And I would do the same thing, but I would just use decimals. So I would take, what did I do first? Over here, I minus the 500. So I would just minus the 5 to both sides. I'm just going to do this one rather quickly. And remember to line up your decimals. So there's no decimal, so it's 5 point nothing, right? Put a 0 there. And we would subtract it out. And we would get 2.25t plus 0, right, equals, because these guys would cross off like that. We would be left with 5 minus 0 is 5. 13 minus 5 is 13, 12, 11, 10, 9, 8, 8.5. Notice how that's going to be very similar to what we were doing. And then we have the plus t, don't forget the t, plus 14. Oh wait, I took it from the wrong thing. Minus 5 has to go over here. Okay. So the 13.5 would stay there. And this would be 14 minus 5.0, or 14 just minus 5. We don't have to worry about the decimal in this case. 14, 13, 12, 11, 10, 9. There, that made more sense. Okay, and don't forget this has still got a t. Now we are going to move the 13.5t to the other side by minusing 13.5t to both sides, minus 13.5t, which will then give us, so we would take 13.5, so I might have to do it like this, 13.5 minus 2.25, put a 0 in there to fill it in. Our answer is going to be negative because the negative is 13. So now we have 5 becomes a 4, this becomes 10. It's going to give us the same thing that we had before, only in decimals. Now we end up with, I just want to make sure I show you that we subtracted. Now we end up with negative 11.25t equals 9. And then we're going to divide by 11.25 to both sides, negative 11.25 to both sides. And that will give us, if you use a calculator, t equals negative 0.8. So we end up with the same answer. So just two methods. If you like working with decimals and that's not a problem to you at all, then you don't need to come up here and multiply by the 100 first. But if you like to get rid of the decimals, you can do that, and then you don't have to work with decimals. Okay, so let's clear that. So that's the shortcut method. The next one I want to do is number 1, I believe, is a good one to do. So let's take a look at number 1. Let's start on a new page here. So let's read it, see what it says. Sandy is upgrading her internet service. Fast internet charges $60, and again, we're underlining numbers. It's a little bit hard to see, for installation, and $50.45 per month. That per is a hint that means rate. Quick internet has free installation, but it charges $57.95 per month. Write an equation that can be used to find the number of months at which the internet cost would cost the same. So same is another key word. So we're going to write an equation over here, and we have our installation fee, that's our flat fee, right? And we have our rate. Our rate for the first one, the company is called Fast Internet, is going to be $50.45 per month. We're going to use M for month, plus 60. And then we're going to have the other one is called Quick Internet, and that one has no installation fee, but it has $57.95 per month. The question is asking us, when will the cost be the same and how many months? So we have to set them equal to each other. When you see the word same, that means we're setting them equal to each other, and that is now a problem that we can solve equation-wise. I am not going to multiply by 100 on this one. I'm just going to solve the decimals. So I am going to move the 60 to the other side by using inverse operations, minus 60. Move this down a little bit. And if I do that, You can go ahead and work this out on your paper too and see if you get the same thing I get. And we now have 50.45 m, the underlining. The 60, positive 60 and the negative 60 will become 0, so we're just going to drop that, equals, now we have 60, negative 60, and 57.95. So negative 60 is going to go on the top, and the 57.95, and I'm sure you've all just kind of cranked that out on your calculator already. Let's just see how it works. So it's always good to check it out here. Okay, so we know the answer is going to be negative because our 60 is negative. That's the bigger number. So we have to borrow from the 6 and make it a 5. And then when you have a lot of zeros in a row, the first one becomes a 10 and the rest become 9s. So we have 2 of them after that that are 9s. And then we go and subtract. 10 minus 5 is 5. 9 minus 9 is 0. Decimal place. 9 minus 7 is 2. And 5 minus 5 is 0. So we have a negative 2.05. We now need to use inverse operations to divide by the coefficient of 50.45 to both sides. 50.45 to both sides. And when we do that, I believe I'm going to use my calculator, but if you want to do the long division, let's erase this, you would set it up. I just want to save and conserve a little bit of time here because we got a couple more problems to do yet. You would then set it up by putting the negative 2.05 on the top and the 50.45 on the outside. And then you'd have to move your decimal 2 over, so you'd have to move this one 2 over. So you'd end up with 205 divided by 5,045. So if I do this, I should get 2.05 divided by 50.45. And did I do something wrong here? 50.45 m plus 60, 57.95 m. That should be right. And my 60 comes off, yep. Oh, you know what I did? I see it. It's good to see mistakes when you see that you made them. This should have an M there. So I missed my M, so that's why. So sometimes when you make a mistake and you look at it and you think to yourself, well, something doesn't look right. If I have to have months, I'm not going to have a fractional decimal answer. That just doesn't sit right. So sometimes being able to ask yourself those kinds of questions is very helpful. And being able to say, logically, does this make sense? So let's just backtrack a little bit for a minute. And what will we do now? The 60 can stay there. And I'm going to just erase all this, and we're going to go backtrack. And we are going to move the M to the other M. So I had missed an M, which made me get an error, right? And then I am going to subtract the minus 50.45 m from that side. So now we should get the right answer. So this is going to leave us with 60 because these are going to cross off right here. These are going to cross off like that. And that's going to leave me with just 60 equaling, and get rid of the underlining. So now we have 57.95 minus 50.45. So that would give me an answer of a 0 here. Oops, I'm going to work backwards. 9 minus 4 is 5. Decimal there. 7 minus 0 is 7. And 5 minus 5 is nothing. So $7.50 M. Now I have to divide both by 7.5 coefficient. And this is one where my M ended up on the other side, doesn't matter. So let's divide by 7.5 to both sides. 7.5, drop that underlining. That will now give us, if I use my calculator, I get 60 divided by 7.5, which then equals 8. And that's equal to M, because my 7.5 will cross off to my other 7.5. So M is equal to 8. So the question said, write an equation, when would the internet services cost the same? They would cost the same after 8 months. And then it said solve the equation. Well, we wrote it over here. So that would be the answer. Okay, this has been a long one for you guys. So stay awake. Got a couple more to go. I'm going to clear all. If you need to pause the video at any time, feel free to do that and come back when you're refreshed or when you've got the answers written down in your book. Okay, I'm gone. And I want to open to page 207. So I'm going to pull that one up. And this is your homework, some of it. So I wanted to just do a couple problems that I felt might cause you some problems. So number 14, this one's a little weird. It says write an equation with the solution x equals 20. The equation should have the variable on both sides, a fractional coefficient on the left side, and a fraction anywhere on the right side. So we just have some stipulations. So we kind of have to work backwards. We know the answer already. We know the answer is going to be 20. So we know x is going to be our variable, And we know that the answer to x equals 20. So let's work backwards with these criteria that we have. So we know we need to have, the equation should have a variable on both sides. So we need an x on one side, and we need an x on the other side. Then we know that we need a fractional coefficient on the left side. So we're going to put a coefficient in front of the x that's a fraction. I'm going to pick 1/4. Okay, and then it says we need a fraction anywhere on the right side. So I'm just going to pick 2/5 for that side. And then just to be fun, I'm going to minus 2 on this side. Now, I have to figure out what this would equal so that I can figure out what I need to put on this side to make it equal. So I know that x is 20, so I already know it's 20. So 1/4 times 20, I'm putting 20 in for my x, minus 2. I'm just doing the left side. So 1/4 times 20 is 20 divided by 4, or 5, minus the 2 is going to give me 3. So my left side is going to equal 3. So that means my right side over here also has to equal 3. So we have 2/5 times 20. So what is 2/5 times 20? Well, 2/5 times 20 is 2 times 20, 40, divided by 5. 40 divided by 5 is 8. But we need it to equal 3, so we have to subtract something else to get to 3. 8 minus what will give us 3? Right, 5. So I'm going to go back up here, and I'm going to have to add in a minus 5 to make them equal. Now I know that my 2/5 x minus 5 is also going to equal 3 when I'm done. So we have our equation. We can put it in here. We have 1/4 x minus 2 equals 2/5 x minus 5. That will be our equation. You can pick a different equation. There's many different ways you could do this. If I'm not sure that I did it right, I can always go back and check by putting in my 20, or actually not putting in my 20, solving to get 20 for x. So my 1/4 x minus 2 equals 2/5 x minus 5. Then I'm going to move my 2 by adding a 2 to both sides. And I'm going to just kind of zip through this. 1/4 x is now equal to 2/5 x plus minus 3. And now I'm going to move my, well, now I feel like I would like to get rid of these fractions. So I'm going to multiply by the LCM to get rid of the fractions. This is a good way to use the shortcut in this one because the denominators are not the same. So I'm going to multiply by 20 to both sides. And that's going to give me 20 times 1/4 is going to give me 5x equals, so 2/5 x times 20 is 20 times 2, which is 40, divided by 5, which is going to give me 8x, minus 20 times 3 is going to give me 60. I'm going to move the 8x to the other side, minus 8x equals negative 60. So 5 minus 8x is going to give me negative 3x equaling negative 60. And then I'm going to divide by negative 3. I'll show that step if you want me to. If I divide by negative 3, both sides, I end up with negatives canceling out, x equaling negative 60 divided by 3 is going to be a positive 20. And that's what I wanted to get. X has to equal 20. So that's my check that I did it correctly. So you can always go back and do that to check. And now I'm going to do one more problem. I'm going to do number 16. So let's erase this and move down to here. Okay, number 16 is a geometry problem, so that's a good one to do. I'm actually going to clear all drawings and move this up a little. Okay, the perimeters of the rectangle, this is the last one we're doing today, are shown, the perimeters of the rectangle shown are equal. What is the perimeter of each rectangle? Well, perimeter means you add all the sides, and you know that opposite sides are equal. So we are going to set this up, n plus 0.6 plus n plus n plus 0.6. Where on earth did I get all that? I got that because I know that this side is n plus 0.6. And I also know that this side is n. Opposite sides are the same length for a rectangle. Kind of want to move that over a little. Okay. So I just took all the way around the rectangle and added them all together in one big long line. And I need to set that equal because the perimeters are equal of both shapes. So the other one, we have n plus 0.1, n plus 0.1 plus 2n plus 2n plus, what's this side? Same as that one. N plus 0.1 plus, and this side here is 2n. And because I want these to all be on one line, I am going to make my font smaller so they fit. There we go. A little bit smaller, but okay. So now we have to combine like terms. So we're going to find out what ones are the same. So we're going to underline all the n's. And on that side. just like that. So now let's combine all of those. We have an n. Remember, the number in front of a variable is a 1. So we have a 1n plus a 1n plus a 1n plus a 1n. So what does that equal? Yeah, 4n plus, now we can underline the coefficients and add those together. So I have a 0.6 and a 0.6. So what's a 0.6 and a 0.6? Yep, 1.2. Now, on the other side, I have to do the same thing. So I'm going to underline all of my letters. We have an N, we have a 2N, we have an N, we have a 2N. So if I add those all together, what is N plus 2N? That's 3N. Plus another N, that's 4N. Plus 2 more, that's 6N. 6N plus, and now I'm going to underline my constants, 0.1 and 0.1. So what's 0.1 plus 0.1? Should be 0.2, right? And I'm going to then, now I can probably make my font bigger again. So now I'm left with a 4n plus 1.2 equaling a 6n plus 0.2. So now I'm going to move my 1.2 over to the other side. Let's move the 0.2 because then we won't get a negative. So let's minus 0.2 to both sides. Minus 0.2. Hang in there. Okay. And that leaves us with a 4n and plus, we have to go 2 minus 2 is 0. 1 minus 0 is 1. 1.0 positive, or just 1. So we're just going to put 1 there. And we might need to put the 0. We'll see. No, we don't. So 1. And that equals 6n, because these will cross off. Okay. So now I have to leave the 1 here and or subtract the 4n from both sides, minus 4n. And if I do that, this should actually become pretty quick for you guys after you practice it. These become zeros. Doing it on the computer actually takes a little bit more time. That's okay. We end up with 1, because we got to draw everything. 1 equals 6 minus 4n is 2n. Now the last step is to divide by, you got it, by 2. So now I'm dividing by 2. Don't want that there. And on the other side, I'm dividing by 2, which then leaves me with 1/2 equals n. Now, what's the question? What is the perimeter of the rectangle? It's always good to go back to the question and see if you answered it, because the answer isn't 1/2. The answer is the perimeter. So now we have to plug in this 1/2 into each side. So we have to plug it in here, and we have to plug in the 1/2 over here. We could do it to both rectangles. The thing is, though, the problem tells us that the perimeters are equal. So we really only need to do it to one rectangle. So we're going to plug that in. If we do that, we end up with 1/2. And I'm going to change the 1/2 since it's a 0.06. I'm going to change 1/2 to 0.5, because isn't 1/2 the same as 0.5? Yes. Plus 0.6 plus 0.5 plus, we got to go to the bottom here. So that would be plus 0.5 plus 0.6 plus, and then we have to go to the n over here, 0.5. So if we add all of that up with our calculator, or we line up our dots, we should get, what did I get for that? I think I got 3.2. Let me double check. That's what I got. Yes, 3.2 units. And we know the other rectangle is equal to that. That would also give us 3.2 units if we plugged it in. So let's go to our homework. I'm going to clear all. And your homework right here, bring it up to the top. Oops, I don't want to do that. Undo. I think I erased something I didn't want to erase. Oh, where'd it go now? Where did the homework go? There it is. Okay, there's our homework. That's what I meant to do. Okay, so our homework then is to read through pages 203 to 205, complete the Your Turn questions that you see in those pages, and then complete the rest of the guided practice questions. We did some of them on this video. So page 206, the remaining questions, and then page 207 and 208, numbers 10 through number 18. We did number 14 and number 16 on the video. Be a good idea for you to rework those as well, though. So that's your homework. And I was thinking that we should do one more lesson before we would have a live session where you can ask questions about your homework from the last video and from this video and the one that will be upcoming as well. So I am going to stop sharing my screen here, and I'm going to become very big. There I am. Okay. Nice to see you guys, and email me if you have any questions whatsoever. You could also, I'm on Instagram. You could connect with me that way. You can connect with me via text message. I left my phone number on the letter that I sent you guys. So any way you want, I'm here to help you. So no question is a dumb question. So anything you have that you want to email me about or text me about, feel free to do that. So I hope you have a good night. Bye.